Welcome, everyone. We are here today to talk about CHIP-21, the NFT Fusion Puzzle from Brant here, who we have in the chat. And the point of this call is to introduce the chip and make sure everybody's familiar with it and how it's going to work. And from there, we'll send in reviews and hopefully get it across the finish line. Why don't we start off with some introductions? I'll just go first. My name is Dan Perry, and I'm a technical writer here at Chia Network Inc. And I mostly am in charge of the CHIPS program. The CHIPS program is, in case you don't know what it is, it's similar to BIPs and Bitcoin, and it's a way to submit proposals for anything from smaller changes or optional Chia list puzzles to major changes to our consensus. And these are formal proposals that require a lot of scrutiny and some time to get them through. But then once they do get through, then if you do submit one, and anyone can submit one, then your name is forever written down in the lore of Chia. So if you are interested in submitting one, then go to the CHIPS repo in Chia Network's GitHub page. So I'll be facilitating this meeting, and why don't we have Brant introduce yourself?
Absolutely. Thank you, Dan, and thank you all who have joined. I want to start out by saying I am the CHIP author. However, I am not the only person involved in the project. So we did have a few others who I'll also introduce. But myself, I do work with CNI. However, this work is outside of CNI. So this is non-Chia network related stuff for me. This is with my entity and Grig's entity, Sunset Tech. And we have partnered with Monkey Zoo to develop the Fusion Zoo project. So you see Tim Youngman is in here as well. He is the creator of the Monkey Zoo project. And he and I had been discussing for well over a year now as to a good solution for on-chain provenance for essentially composable media. And the concept behind that is being able to take small bits of some NFTs, combine them together and create a whole new NFT, but ensure that all of the provenance is still tracked on chain with the ability to claim back previous NFTs. The other members who helped develop this project, Grig, my business partner, he did a lot for the concept version that we have built out for Monkey Zoo in order to tie not only the Chia list puzzle, which is the main focus of this chip, but a full suite of tools to interact with that Chia list puzzle so that we could bring the Fusion Zoo project to light for Tim Youngman. The actual developer behind the Chia list puzzle itself is Lucky 8. Worked with him for well over a year now, and I know Andreas has worked with him as well on the royalty split puzzle last year. And then, of course, going back and forth with Lucky 8 as to different methods for implementing this fusion puzzle has been a lot of fun over the last year. And we'll get into the nitty gritty as to how things changed kind of last minute on us and where we are at throughout that process now. The other developer that we had helping us out for this is Garrix, and he works on the Spriggan project. But he has done a wonderful job at building out the UI for the Fusion Zoo project, kind of bringing this whole thing to life and showing users how they can interact with such a complex puzzle in an easy way. So that's kind of the core team who helped develop this project. The story behind the Fusion puzzle itself is Tim and I were, I believe, on one of the Twitter spaces one day and kind of bouncing around ideas. And this was about a year and a half ago as to what the Monkey Zoo project could do in the future. Greg and I had always been talking about building some form of composable media, and we really want to do it for music, to take different tracks, combine them together, create a whole new song out of it, and still have that provenance back to the original creator. Tim absolutely loved that concept and said, I want to do that, but I want to do that for the monkeys. And this is going to be Cheeky Monkeys. This will be the special edition collection. This will be pretty much everything under the Monkey Zoo realm we want to allow to be utilized within this process. The end goal of the Fusion project is, as I had mentioned, taking one or more NFTs, taking attributes from them, and either combining attributes from multiple NFTs or altering them in some way, shape, or form to create a whole new NFT that is the user's creation, minting that new NFT on chain, and utilizing this Fusion Chia list puzzle to develop a smart contract to allow a seamless exchange between the original component NFTs and the new NFT. So that means you essentially have two sides of this puzzle. You have an input side and an output side. For the Fusion project, the input would be all of the component NFTs, and the output being the user-generated NFT itself. The puzzle allows for the user to interact with an offer file, and not only can that one user interact with that puzzle, but any owner of the NFT in the future can also interact with it. So say there's an instance where I sell off my combined NFT and somebody else wants the parts that created it, they can go ahead and interact with that puzzle in order to gain the parts. So that's kind of a quick high-level overview. We can dive into the nitty-gritty here if you want, Dan, and I also have a video to display of kind of the fusion process as well.
Oh, great. Okay. So why don't we get into the nitty-gritty as you suggested? Would you mind sharing your own screen to show the chip itself, or would you prefer that I do that?
I can do that. Absolutely.
Okay.
Let's see here.
For those of you in the audience, if you come up with any questions, I'd suggest either you save them to the end and we'll do a Q&A session, or just type them in the chat and we'll get to them in a little bit. Thanks for the great introduction, by the way.
Absolutely. Thank you. All right. So I have the chip loaded up locally here. Once Zoom wants to stop doing all of its things, there we are. And so I have the chip loaded up locally. You'll notice again, I am the author on here. However, we have proper attribution for Lucky 8, for Garrix, and also our partner Monkey Zoo in the development of this puzzle. The main goal of the Fusion side of it, taking multiple NFTs to create one new NFT, is only one use case that this puzzle can fulfill. So I've also gone into depth to describe a few other use cases, such as updating NFTs, breaking NFTs apart, or upgrading them, such as in a gamification scenario. As you will scroll through here, one of the biggest notes is that it does require CHIP-21, and the puzzle itself does not mint the NFTs. You still need to ensure that if you're creating new NFTs to fulfill this puzzle, the original DID is the proper DID being used for minting. So that's kind of one of the big call outs there. And it does require CHIP-21 just because of the recommended metadata that allows for easier tracking of that on-chain provenance. The motivation behind it is bringing NFTs to the next level. We've seen a few other chips come through to, say, edit metadata within NFTs. We, at the beginning of this year, Greg and I had CHIP-15, which is extended metadata for NFTs as well. And the core concept is taking these non-fungible tokens and being able to utilize them as you would a standard asset. So that means being able to change it around, do what you want with it, but still retain that non-fungibility of the original NFTs, which allows for that true on-chain provenance throughout the whole process. The backward compatibility really relies in the metadata being used, and we went ahead and tied into CHIP-15 metadata because it is fully backward compatible with CHIP-7, and it is a standard that already exists within the CHIP standards for the Chia blockchain. One thing I want to note right here, and this is something I've not yet written into the chip. However, it is going to be one of the most important things and probably one of the most controversial things about the Fusion puzzle. And that is that the Fusion puzzle does kind of make it a little easier to dust the blockchain and encourage fee pressure. By that, I mean, once you create this process, you're essentially exchanging the same NFTs with yourself via this smart contract. So if we were to load up, say, in my testing, I was able to reach a total of 38 NFTs on one side of the contract with one NFT on the other side, but that was at about 89 to 90% of the current block limit. So for the Fusion puzzle, we have hard limitations in place to ensure that we never exceed about 50% of block space. However, those are not pre-existing within the Fusion puzzle itself. So that is something that anybody utilizing this will want to be aware of, is that if you allow too much on the input side or too much on the output side, you can very easily create a fusion puzzle that is too large to move on chain. The other thing I've identified is that the diffusion side of it, which means after you have all of your NFT components inside of the smart contract and you want to get those back for that created NFT, that's the diffusion side. That is a slightly higher cost than the fusion side. And that's just because there are more NFTs within that smart contract that rely on a special ownership layer affirmation within the signing portion of the spend bundles. So I just want to throw that out there. I am going to include that in here, but I want to make sure I first presented that to everybody. And please do post any questions or comments regarding that inside of the chat here, and I'll get to those at the end. The rationale behind it is, again, CHIP-15 metadata allows us for easier integration and future proofing, allowing additional data to be quickly added. Plus, the CHIP-15 metadata really allows for all those other use cases. Once we get into the actual metadata section here, you'll see how that data will be entered in and why it's so beneficial to the puzzle itself. The use of offer files was the big changeover here within the last few months. Originally, when we were looking to build out this puzzle, we were looking to develop custom spend bundles that a user would then have to sign themselves. However, what we ran across is that there's very little support across the ecosystem for custom spend bundles. It would rely on CHIP-2 at that point, kind of the DApp chip. And unfortunately, there just are not enough wallets that kind of support that concept right now. So what Lucky 8 did is he took another look at the base design for how users are going to interact with it and elevated the puzzle from a direct signing method of custom spend bundles to utilizing offer files. So it's really a nice way to do it because that means we get to utilize Wallet Connect to interact directly with the user and have all of that fun functionality. The next design decision is the use of an actual singleton. We obviously could have just created a puzzle on chain that does all of these same mechanics, but we wanted to make sure that we could identify state changes as well. And that was the reason for the use of a singleton. So you can utilize those hints, you can identify the contracts a lot easier, and you can also identify the state of those contracts as they exist on chain. The main part of it, though, that I know Tim really appreciates is the decentralization aspect. And that is the core premise behind utilizing an on-chain puzzle. This is really what brings the current concepts that we see out there in other blockchains to the next level by saying anybody can now interact with this puzzle in the future and can then break down that NFT back to its core parts. So there's a lot of, I'm sure everybody's minds are going wild as to what they can now do with this puzzle for composable assets and breaking them down in the future and allowing that true provenance for every creator involved. So those are kind of the core design decisions there. The alternatives, oh, actually, there was one other one in there. When we were first looking at the direct signing option, we not only wanted to make sure it was secure, but we also did not yet know whether or not we'd be able to do both sides of that. And that means the fusion side, where you're taking multiple NFTs to create a single one, and also the diffusion side, where you're taking those multiple NFTs and bringing it back down to the single one. Since we did not know as to whether or not that would be fully capable within the same puzzle initially, we were thinking about having a master key set involved in the puzzle for an escape spend, which would have allowed the original owner plus a master key set to create a signature that releases any of the NFTs out of the puzzle. That has since been removed entirely from the concept, just because it fully utilizes the on-chain mechanics as well as offer files to interact with the puzzle. And this means there's nobody out there. Once you lock that into a smart contract, the only person who can interact with those NFTs is the person who owns the correct other NFTs. This leads to some of the alternative designs. We could have obviously done everything offline in a trusted manner, where users have the same UI experience of building the actual NFTs, but then everything thereafter, instead of being on chain, is done offline. We really wanted to have that decentralization aspect and remove that trust requirement for any project involved. So really the only trust level that you have for the Monkey Zoo implementation of this is that Monkey Zoo is going to mint the new NFT and send it to the contract for you to interact with it. Now, that step has to be done before the user could ever interact with that smart contract. So even then, the user is safe and they don't have to worry about losing their NFTs or breaking them in one of these contracts just because they know that the other side is going to be inside of that contract before their wallet ever interacts with it. A lot of additional information as to why the design is in place is in here as well. And then you'll go into the specification side of it. This specification side relies heavily on the actual Chia list puzzle, which we have multiple links to in here as well, and goes through the full process of deploying your own smart contract, utilizing that Chia list puzzle. Lucky 8 went out of his way to ensure that anybody who touches that repo can test it out right then and there. So he also included the minting of some fake NFTs. He included the whole process of showing you how to create the offer file on your side, and then also how to utilize the Fusion code base to generate the other side of the offer file, which is essentially that release spend out of the puzzle itself. The main parts that we want to see from the ecosystem is to aid us in the integration of the Fusion puzzle. There's a couple of components involved. Obviously, NFTs are now going to be locked inside of these Fusion puzzles. So if I want to create a new NFT from 4 of my other ones, my 4 NFTs are now going to be locked inside of that puzzle. We are going to be populating here in the future, or circulating, a list of those different Fusion contracts and also methods to utilize those singletons to identify the contracts on chain. However, it would be great if we could have some display services such as marketplaces and explorers start to identify those on-chain smart contracts and also potentially add a note to them that says, hey, this is a Fusion contract. You can find these NFTs on chain, but guess what? They're in a Fusion contract. So this could be on the side of when you're just looking up that XCH address that relates to the contract, or it could be when you're looking up the NFT and seeing who currently owns it. It would be really great to see, hey, it's a Fusion contract. This is locked up. And then, of course, that leads to the next stage of, well, what did that Fusion contract do? So if we could have display services, this could even include wallet clients at this point, aid in the display of that provenance and showing, okay, we recognize that this NFT came out of one of these smart contracts, but what are the components to it? And I think it would be really cool to have the display services help show this is the current NFT. It came out of the smart contract, and here's where you can follow it back through the Fusion puzzle. Or, of course, the flip side of saying, hey, guess what? This NFT could be used in a smart contract, one of these Fusion puzzles, and here's the one it can interact with and show these are the other NFTs that you can create by defusing the one you own. The available interactions are kind of what would be shown there. The defusing, reverting updates, downgrading. Essentially, once that NFT passes out of the original owner's hands, what can be done with it by the future owners? And then, of course, the total number of Fusion puzzles and total number of NFTs associated with Fusion puzzles would be great statistics to have on this as well, just to help show the adoption rate. Display services here, again, just kind of means marketplaces, explorers, wallet clients, anybody who might be displaying the information to individual users. And then, of course, there are considerations for minting solutions. The entire Chia list puzzle is provided, as well as different use cases and test cases. So any minting provider out there could integrate this puzzle directly into their minting tool. And that would allow other creators to take advantage of this Fusion puzzle, maybe not just for the Fusion side of it, but maybe for helping to upgrade NFTs, or say somebody created an NFT with a typo in it. The current way of doing it right now is burning that NFT and creating a new one. What this puzzle allows is you can actually mint a new NFT and lock it into that smart contract, so you have a direct tie from the typo to the corrected version. The cool thing about this is that, as we know, there's a whole group of traders out there who prefer to see those mistakes. They want that, that Charizard that has a cut through it. And that's kind of what this would allow is, hey, anybody can revert back to that deprecated version of the NFT at that point. There are a few different examples here as to the Fusion example. And what these will show are how to utilize that metadata. So we do have full breakdowns of everything in here. Again, all of these metadata fields are out of CHIP-15. So they're essentially schema.org metadata fields. This means that all of the metadata will reside in the data object of the off-chain metadata, have the reference to the schema.org context, and then it can also describe what occurred with it. In this particular fusion, we're looking at an NFT that was created from a couple of other Monkey Zoo NFTs. So you can see that some of the parts it has are red shorts from this particular NFT ID. It has brown eyes from this particular NFT ID, and so on and so forth. What this allows display services to do is not only more readily identify which NFTs are involved in the creation of this particular one, but also validate any of the on-chain information with this metadata or vice versa. So you can see some great combinations in here as well. The other side of it is the main entity. The main entity that you'll see included in all of these. And that is that original NFT that was a component to create this new NFT. So that kind of shows the metadata of a Fusion example. And you'll notice it had all of the components that created the new NFT. The other side could be, say, changing NFT attributes. And this is where maybe somebody minted an NFT and had a typo in it, and they just want to update that typo real quick. A similar context here is that you would still have has part. You'll just find a much more refined list. So maybe, red shorts had a typo and it had a Z in it. So we went ahead and updated it to an S in the new metadata. And that could be a quick way to identify this was the old property and this is the new property with which we're replacing it. And then, of course, upgrading NFT attributes. This could be very useful in gamification scenarios where maybe you have a game on chain and somebody's upgrading their character. And you'll notice we do have different property IDs to kind of show, this is an upgraded attribute, this is a fused attribute, and how it was interacting within that puzzle as well. So maybe those, red shorts turn into flaming red shorts after the upgrade. And within the Monkey Zoo project, I'm sure everybody out there knows that you get MZ token based on your NFTs. So maybe when you do an upgrade, you get more MZ token for it. The other side of that would be the breakdown of NFTs, which would be very similar to the Fusion concept, where you have each of the parts properly identified and how they all feed back to it. So you'd have a main entity identified as well as those individual attributes as well. I'll load in some additional test cases here. We're working on a final bug within the code base, and it's really one of those ease of access bugs that kind of exist within there for ensuring where the fused NFT is. So this is that side B when you're creating it, where that fused NFT resides when the first offer file goes through. We could have a requirement where you actually have to send that NFT from the minting wallet to the Fusion contract and then interact with everything. Or the flip side is we can actually design a new offer file solution where the minting wallet can still hold on to that NFT and create the proper offer file so that any of the component NFTs are sent to the proper contract and kind of save us block confirmation time, which obviously will save time and make a better user experience because they're not sitting and waiting for more block confirmations for the process to go through. See, I have a typo in here as well. The beauty of the security is that it does rely on a lot of Chia Lisp assert conditions, which tie all those NFTs together with their ownership layer as well. So it's essentially a Merkle tree hash of the actual NFT IDs, and those are what is proving the ability to spend the NFT that's locked inside of the contract. The other side of it is the utilization of offer files to make a more seamless experience within that security layer as well. So you're not worried about having to generate that entire spend bundle yourself. You can utilize the code base within the Chia Lisp repo and create those offer files from there. Then, of course, we have the additional assets, which include the full metadata examples of the ones we just went through. And I'll also add in additional details as we see fit. I know like the video I'm going to show y'all will be included in there as well. So I'm going to go ahead and start the video here, and I'll kind of answer questions while going through the video. What the video is going to show is interacting with the Monkey Zoo Fusion Zoo project. So you're going to see the utilization of Wallet Connect to identify NFTs that exist within a user's wallet, the manipulation of those NFTs to create a brand new NFT. The user will have to wait for that new NFT to be minted on chain, and then the user will actually create the offer file that creates the exchange. Oh, sorry about that. All right, so we are loading up the NFTs. And of course, everybody's kind of familiar with that Wallet Connect experience. Once you've loaded up those NFTs, you'll notice we created a bunch of test assets so we can mess around with different components, but it will go ahead and load up your NFTs, allow you to choose specific attributes from each NFT, or say, choose the entire NFT as well. After you've chosen all of those attributes, you can take a look at the preview there, select a particular layer, manipulate that layer, or say delete particular layers, and really create that NFT that you want to create at that point. So I know Greg always has a lot of fun with these, and kind of increasing that eye size, changing some things around. But really the core of the concept is, if you look at what Monkey Zoo has been releasing lately with their jungle packs and their oddments collection, the concept behind those is to utilize them within the Fusion Zoo. So you can take a banana staff and give it to your monkey. You can take an OG crown and give it to your monkey as well, and really kind of create your own cheeky monkey from whatever NFTs you own. And this really goes back to that core concept within the Monkey Zoo project of, once you purchase one of these NFTs, you really have a lot of rights and license to utilize the image and to really make it your own and utilize it for whatever purpose you see fit. So here we're taking a couple of eyeballs from different ones, and maybe we're going to throw these eyeballs on the feet instead, and kind of have that fun manipulation and that changeover to whatever we want here. And then once we get into the nitty gritty, we will start the minting process of this NFT, but you'll also notice that we display the full metadata. We have yet to determine if the user will see that, or if it'll be a hidden, hey, advanced information option that they'll have to click on in order to see that metadata. But our system does generate this on the fly. If anybody here is interested in helping us test this puzzle, we're finishing up some closed internal testing throughout this week and probably next week. And then we're going to open up to a smaller group of internal testing thereafter. And then we'll start launching kind of that beta testing access. So now we're at the point where we have combined all of our NFTs together, and we have started the fusion generation process. So you'll notice after we click that, it actually renders the NFT itself. After it's been rendered, the full NFT is minted on the Monkey Zoo DID side. The necessary data for the offer file is sent back to the user, and the user gets to create and view the offer file itself, plus confirm it on chain. Now, the one thing for those on the developer mindset who are looking at that you'll notice is that the offer file that the user creates is only one half of the offer file. And that's the user creating the offer for their NFTs that they own. That's essentially the unsigned spend bundle. They're creating the first half of it. After that, the offer file is transmitted back to the Monkey Zoo server, and we utilize the Fusion Chia Lisp code in order to build the other half of the offer file. That's where the special coding comes into place to ensure that the NFT can be released from the pay to address of the singleton and sent back to the user. So there are two sides of that for the creation of the offer, and then of course the acceptance of the offer as well. But then it's pushed to the blockchain, and it's one more confirmation, and the user has the other side of the NFTs in their wallet at that point. And that's kind of a quick rundown of the puzzle itself, as well as how to interact with it and how we've implemented it within the Monkey Zoo project. I'm getting to one of the questions here from Brandon. And let's see here. This might be, hey, Tim, I don't know if you are, Lucky 8, I don't know if you're available for a quick question on this, but it's a design decision on the singleton itself. Let's see here. Looking at the Fusion Chia Lisp, the Fusion Singleton puzzle appears to be a custom variation of the Singleton puzzle. Is there a reason to do this instead of using a nested inner puzzle for custom behavior? And Lucky 8 might not be available right now to answer. Oh, looks like he might be.
I'm available. I thought we were using the singleton top layer and in using that. I have to double check some things to be able to give an answer to that, I think.
Certainly. Yeah, no worries at all. Yeah, and that's my understanding as well, is that we're utilizing that top layer and we're essentially replacing some of the components within that inner puzzle. But we'll look more into that for you there, Brandon, and we'll get you a much more solid answer here within the next day. Outside of that, what other questions do we have?
Yeah, thanks, Clyde, or thank Brent. Yeah, that was great. Thank you so much. This is really exciting. I had a few questions for you. Along the same lines of the singleton. I'm not sure if this was totally clear or not. Is there just one singleton for every fusion that's being done, or are they somehow, or multiple fusions can result in one singleton being spent over and over, or how does that work?
So each of these fusions will have its own unique singleton associated with it. So you'd be able to identify any interaction specifically to that fusion itself. And that goes back to that one of the design decisions behind, do we do something like an account-based model where you have a group contract that there's one point of failure, or do we have multiple different contracts, in this case, multiple different smart coin puzzles, and utilize those. And so we opted for the latter for security purposes and also distributed points of failure at that point.
Okay, thank you. Next thing that I wrote down, and if anyone else wants to preempt me, I just have a few more questions. Next one that I had to do with the cost again, that you said you were going to add. Would you mind, when you work on this later, adding, I'm sure you were going to do this anyway, but adding the CLVM costs for some various different inputs and outputs, just to let us know how big we're actually looking at?
Absolutely. Yeah, my initial testing was essentially, once you got up to that 39 NFT mark on one side, you're going to be at block, at max block. But I'll go ahead and relay the direct cost for each of those as well inside of that.
Okay. Yeah, that's pretty big. So that's assuming the 5.5 billion that cost that we currently have in a block, or the 11 billion total.
The 5.5 that's currently in a block.
Okay. Yeah, so it's really costly, but to be honest, I don't think you should be quite as concerned about someone just spamming the network, because they can do that anyway. I mean, someone already figured out how to dust the network, so exactly. That's a known thing. But for people who actually want to use this in its normal way, then that could be potentially an issue, if especially if fees get bigger on the network in the future. But something to keep in mind. Yeah, as long as we just know what it is ahead of time, then everybody can decide for themselves.
And one of the recommendations that I'll also add inside of the chip, in case somebody runs into those cap limits, are cascading fusion puzzles. So you essentially have, within the Monkey Zoo project, we're going to create a hard limit. And once you reach that hard limit, say you want to still combine more NFTs, well, you first do that initial fusion so that you combine everything into the one NFT, and then you do a secondary fusion with that fused NFT. So essentially, like we've seen with the royalty split puzzle, where you can have cascading royalties and have those puzzles interact with one another, that'll be a recommendation for the fusion puzzle as well.
Okay, so that should be helpful too then. Thanks. So absolutely. Brandon, you have your hand up?
Yeah, so you said that the Fusion Puzzle allows you to divide NFTs and mint new ones with certain parts of those NFTs, correct?
Mhm.
So if you were to take one NFT that has multiple components on it, would it be possible to use some of those components for one NFT and some for another, for example?
Absolutely. Yes. Yep. The puzzle fully supports one or more NFTs on one side and one or more NFTs on the other side. I just want to reiterate that, again, you need to make sure that if you are splitting NFTs and have to create new NFTs, make sure you have the proper minter DID that is minting them. Generally, that means that the project creator will end up performing that minting action, or depending on the licensing, it could be the end user. Say you have a license to manipulate an NFT image, so you might use the Fusion Puzzle to show, hey, I manipulated that NFT, but here's the original one, and provide that attribution. So that's just one thing I want to reiterate there.
Yeah, for the NFT metadata, each of the attributes are essentially different things that you can combine, correct? So if you were to create two NFTs on the output that use the same attribute from one of the input NFTs, is there anything to prevent that? Or is that something you check off chain?
That's something you would have to check off chain. Yep.
Okay. And then I guess the only other concern I'd have is this is kind of making NFTs fungible in a way.
No, absolutely. And that's kind of the careful balance is, how do you retain the non-fungibility of the unique NFT itself, which is, in this case, the one that would end up being locked in the Fusion Puzzle, while still allowing for those unique and robust interactions with those NFTs. So instead of having something like the editable metadata chip that was out there, which would allow you to go in and essentially do similar concepts from a strictly metadata perspective. And what this puzzle does is it still retains that non-fungibility of the original NFT, ensures that that record remains on chain and untouched, and just assigns it to that smart contract so that then you can look back through the chain of provenance to validate and audit what had occurred throughout the process.
Yeah, and so essentially you're locking up the original NFTs and creating a new one. And if you were to create two output NFTs and send one to someone else, there's a way to combine them again and get the original NFTs out if you both agree?
Correct. Yep.
Okay. Cool.
Absolutely. But as you alluded to there, you would have to have both of those output NFTs to recreate that input, or to gain access to that input NFT.
Yeah, that's interesting. You could make some pretty valuable NFTs that way.
Absolutely. And as you very directly alluded to, it could run into this situation where, maybe you have an NFT that somebody else needs to complete a fusion, or, the concept of a puzzle. You can do a fully on-chain puzzle where you have a whole bunch of different puzzle pieces scattered around Dexy or around Mint Garden or whatever your preferred marketplace might be. And you have to purchase all of the different puzzle pieces in order to combine them to create whatever NFT is locked in the contract. So you can really create some interesting scenarios where you increase the interest and the value of the component NFTs. And then, of course, it helps with the emissions in the long run, because now you're locking up a number of NFTs and reducing them, or you're increasing the NFTs based on what's on chain.
Yeah, that's pretty cool. Thank you.
Absolutely. Great questions. Thank you.
All sorts of possibilities out there. It's kind of amazing. Brant, one thing maybe this is already clear, but I might have missed it. With the marketplaces and wallets and whatnot, when they're trying to identify these NFTs as being a fusion puzzle, can they identify them? Is that in the metadata, or is there a hint in the coin, or how does that work?
So there is metadata to identify it. There is a coin hint, and we will likely also be circulating a list of the Fusion contracts that we create at the very least.
Oh, okay. But even if they don't have some sort of centralized list, then they can always identify it through either of those things, I guess.
You got it. And that was one of the design principles behind using a singleton rather than a standard just puzzle contract like the royalty split was done last year.
Got it. Okay, thanks for that.
I think it might be worth adding information on how to discover these coins to the chip.
Will do, absolutely.
Yeah, good point. Totally. Only other question I had was just kind of where are you at with this? You look pretty far along in the process. Are you still developing the puzzle, or what are we looking forward to here in the future?
We are identifying edge cases right now and working to resolve those edge cases to ensure that there's a seamless user experience as well as a seamless developer experience. So we've gone through thorough testing on chain directly with the Fusion puzzle itself. And now with the stage we're at is the additional testing with the integration for the Fusion Zoo. Once we finish our closed internal testing, which I anticipate to be done within the next week or two, then we're going to open it up to a slightly larger internal testing group, which everybody here is welcome to be a part of. And the way we foresee that one going is it'll likely start with test assets. So you might send us an XCH address and we'll send you some test assets. So you don't ever have to worry about breaking your own NFTs. You'll be able to interact with the Fusion Zoo, be able to test it out, see what's occurring on chain from the results. And then we would go into the real asset testing at that point, where it's real monkeys that are being locked in these contracts. You can see everything on chain and how it's interacting on the back end as well. And then, of course, we'll launch a beta of the Fusion Zoo project at that point as well. So then that's kind of when everybody else gets to get their hands on it and really start messing with their monkeys. So I would definitely say by the end of this year, you're going to you'll have your hands on testing and you'll definitely have some hands on the beta access as well, so long as no additional bugs or issues arise, of course.
Great. Were there further questions from anybody else?
I was just going to just do a sort of an overview and thanks Brant for well, everything that you, Tim, Greg, and the rest of the NFTR guys have done. You know, the essential part of this this chip and the idea behind this is to really start introducing this to gaming assets. And you know, the way that we currently use gaming assets, you know, you do attach various pieces to your characters, etc., etc. And you know, I see this as the first step of being able to do this in a sort of truly decentralized way that can't really be done on other chains, which you know, really attracted me to why we're building all this on Chia. So I think you know, this is the very first step of this, you know, and I'm very much aware that as time goes by, probably most of this will end up on some form of layer 2, etc., utilizing data layer 2, you know, to allow the various games to see and be able to tell which games hold what assets and which items are fused together, etc. So, you know, it's a big milestone for me personally, to get to this sort of stage, and I think it's certainly a big milestone for the Monkey Zoo project, because it's you know, this was one of the things that I wasn't ever sure that was going to be capable, and you know, Tim and the guys have really pulled out of the bag. So yeah, very grateful, and I'm looking forward to sort of progressing this next year and hopefully introducing this into some form of sort of proof of concept game that can utilize this technology as well. So yeah, that's sort of it from my point of view. But yeah, big thanks to the guys that have worked so hard on it. So thanks very much, guys.
Hey, and thank you also. Really appreciate the opportunity to work on the project, and you know, very excited to see where it's going to go from here.
All right. Well, I'll do one last call. Thanks for that, Tim, by the way. We'll do one last call for anyone else who has questions before we wrap up. It sounds like no. So the next steps for, at least with respect to the chip, when you guys, right now it's in draft right now. So if you want to leave a review of the chip in the actual GitHub repo, then go right ahead and do that. You can also discuss the chip in the chips channel of on Discord if you're on that. And once you guys are, I'd say once you have your beta program out, then we'll go ahead and move the chip into review. And then that's where you can give one last chance to review. And then hopefully there's no more big changes needed at that point. And and sounds like that's going to be maybe by year's end, maybe early January, something like that. And then once the review phase is done, it'll take a couple weeks probably. Then we can put it in the last call and eventually, and that's 2 more weeks before we finalize it. But you guys can feel free to have your project up and running before we finalize the chip too. So don't let me slow you down or anything.
Good. Thank you. Yep. And then I'll also make sure I add in the additional cost information as well as the coin hinting information.
Great. And we'll just continue this discussion both on Discord and in GitHub in the actual chip.
Sounds great. Thank you very much, Dan. Appreciate the time.
Okay.
Thanks everyone.
Thanks for presenting, Brant, and thanks also everybody else.
Yep. Thank you all. Let me know if you have any questions, and see you around. Have a great day.
See ya.